Hi, and welcome to Oxidation Numbers. This is actually 19.2. Here's a sparkler. When a sparkler gives off bright light, there is an oxidation reduction reaction going on. Okay, we're going to talk about oxidation numbers. These are like charges, but they're what I call faux charges. So what is it? It's a positive or negative number that so it can be positive or negative that we assign to an atom to indicate its degree of oxidation or reduction. So things that like to be oxidized get a plus charge or a plus oxidation number, and things that like to be reduced get a negative number. So it's kind of like a charge, but it's really not, okay? And if it would be a charge, again, the more electronegative element will get the negative number. The simplest thing to know about oxidation numbers, if you do have an ionic compound, you're going to give exactly the same oxidation number as its charges. So here you have +1 and -1. The only difference is that, you know how I said it really doesn't matter when we're talking about charges which you do first? You see, this is how the convention is now. You have the charge, the plus and minus after the number. Oxidation numbers always have it before. That's all. And it's kind of a small difference, and in reality, chemists don't usually bother with this convention. Okay, so water is a molecular compound, so it doesn't have charges. So we have to think about how we can do that. Well, we know oxygen is more electronegative, and what we do is if we treat it like an ionic compound, it would be a -2 because it's in group 6. And hydrogen is in group 1, so it's a +1. There's 2 of them, so therefore it's H2O. Okay? So it's basically the rules that you learned for charges would work here also. So sometimes we write the oxidation numbers above the chemical symbols, but most of the time you'll see them written just like you would charges. Now this is the most important slide of this series. It gives you the rules, and you might want to take a screenshot of this. So the first rule is if it's a monatomic ion, then you basically just use whatever its charge is. And if it's something like a Fe, you know you could have multiple charges there. So in this case, they show you Fe3+. We also know there's a 2+. So it depends on the oxidation number. Hydrogen is always +1, except in metal hydrides, which are usually mostly group 1, and a hydrogen where it's -1. Oxygen is almost always -2, except in peroxides where it's -1, and when it has compounds with fluorine, because fluorine is more electronegative, and then oxygen will be positive. So for the most part, it's always -2, except for these 2 exceptions. If you have an elemental form of a compound, you will have oxidation number of 0. So for instance, if I was writing K in an equation, that's why sometimes you see me do that. Or with N2 or the diatomics, I can do the same thing. It's saying that it's the neutral elemental form of the compound, or the element. Okay, for a neutral compound, the sum of the oxidation numbers equals 0. And for polyatomic ions, the sum of the oxidation numbers equals the charge of the ion. So for instance, if I have NO2, this is -2, so that's -4, and this is +4. That's going to add up to 0. If I have SO4 my polyatomic, which is 2 minus, then I have minus 2 for the oxygen, that's minus 8, and this would have to be plus 6, because it would add up to minus 2. Okay, that's it. All right, so let's look at this, and we'll work through this together, and then I'll ask you on Play Pause It to do a couple of those. So these are all possibilities. So SO2 so that's minus 2, so that's plus 4, minus 4. So this has to be plus 4. This is going to equal 0. Okay? Now, B is carbon and oxygen, but it has a minus 2, so they have to add up to minus 2. So if I do CO3, oh boy, oh boy. If I do CO3, it doesn't want me to do things this morning. Okay, let's do CO3. So this is going to equal minus 2. Okay, so there's a minus 6. So this has to be a plus 4. And that's how we do it. Okay, I'm going to have you do these two on Play Pause It for me. Okay, so let's walk through some problems. All right, there's the SO2 that I just did, and there's the carbonate ion. So I'll let you look at that for a second. And here you can check your answers for sodium sulfate. Notice in this case we have a polyatomic. We can do this a couple of different ways. Okay, we can add them up. What I would do is, you know sodium is the plus 1, so you're going to have to end up to the minus 2, which makes sense because SO4 is that. So you would treat it as a polyatomic ion. And NH4, again, you know hydrogen is plus 1 always, so then you have to determine what the N is. So you can figure that out as shown here. Okay, and since it's ammonium sulfide, once we know what that is, we can, minus sulfur is going to always be a minus 2 in this case, since our ammonium is plus 1 and we have 2 of them. All right, here's another chance for you. I'm going to ask you to determine the oxidation number of chromium in each of those compounds above, okay, using the rules we just went over. And you can check your answers right here. Okay, how are oxidation and reduction defined in terms of change in oxidation number? Okay, this is where we're going to have something called Leo the lion says grr. And Leo, I better make that a nice O, loss electrons is oxidation, gain electrons is reduction. So here we have a copper wire put in a solution of silver nitrate, and we see a change. It turns blue, which is a sign of the copper ion, and we get a coating on the copper that's kind of silvery. So that means the copper is becoming probably copper 2+, and the silver in solution, which is Ag+, is becoming AgO. So it's gaining electrons, so it's reduced, and the copper must be oxidized. It loses electrons. All right, so there we see the two different situations. This is a reduction. It's coming out of this solution and going here, and this blue color is an ion of copper, copper 2+, and so it's being oxidized. So one thing has to be reduced and one has to be oxidized. So we have copper 0 to start with, and it's going to copper 2. So it's lost 2 electrons. Silver has gained an electron. Okay, so there's our balanced equation. So this helps us also to balance our equations when we use oxidation numbers. Okay, so here we take an iron nail and we dip it into a solution of copper sulfate. In this case, we can see that the blue color gets a little lighter, and we basically turn them into copper. So if you look at the bottom of the nail, you'll see that it's getting a copper coating. So the copper ions in solution are becoming reduced to form copper metal, whereas the iron of the nail is going to start going into solution. So we can use oxidation reduction and change in oxidation number. An increase in the oxidation number, meaning it gets more positive, indicates oxidation, and a decrease means it gets more negative, indicates reduction. Now be careful, because sometimes it could go from +2 to +1. That's getting more negative. Or it could go from -2 to -1. That's getting more positive. Okay, let's go back to our sparkler. Okay. So the metals, as they burn, they gain oxygen, so they undergo oxidation. So they lose electrons, okay, and give them to the oxygen in the air to form compounds. So a substance that undergoes oxidation has an increase in oxidation number. Therefore, as metals burn, their oxidation numbers increase. Okay, let's identify some of these oxidized and reduced atoms. All right, so I'll do the first one and I'll let you try the second one. So if I'm going to write my oxidation numbers in, here's a Brinkelhoff, so we know that's 0. Hydrogen is always +1. Bromine, there's one of them, so it's going to be -1. Hydrogen +1. Chlorine -1. And bromine is by itself. So let's do this. This is our chlorine. This is our bromine. And notice the hydrogen is the same on both sides, so we don't have to worry about it. So this goes from 0 to -1. So that's a reduction. This goes from -1 to 0. It's getting more positive, so that's an oxidation. So this is oxidation. This is reduction. Let me do this one too. Here's 0 and 0. We know this is going to be a -2. This has to be a +4. So this is getting more positive. That's oxidation. It's getting more negative. Reduction. Okay. Okay, here's a summary. Now, sometimes we say something that's oxidized is called a reducing agent, and something that's reduced is called an oxidizing agent. These are terms that are kind of becoming old-fashioned, but we still use them. The thing that I really want you to know is what is being oxidized and what is being reduced. Just know that if you put the word agent, it's going to be the opposite word. Okay? That's all. All right, so this summarizes what I just did. Okay, so you always should evaluate your answers. It makes sense that what is oxidized in a chemical reaction is the reducing agent, excuse me, because it loses electrons, becomes the agent by which the atom that is reduced gains electrons. Conversely, it makes sense that what is reduced in a chemical reaction is the oxidizing agent because it gains electrons. It is the agent by which the atom that is oxidized loses electrons. Kind of summarizes that. That's a little bit confusing. Make sure you know you're able to tell what's oxidized and what's reduced. Okay, this is a more complicated situation. We have 3 reactants and we have 4 products. But the thing to worry about is really what's changing. Some of these things will change. So usually there's only 2 things. Something is becoming oxidized and something is actually becoming reduced. So again, we're going to identify the relevant concepts that we talked about, and we'll put in our numbers. So we see here that zinc starts out as 0, oxygen is -2, magnesium would be +4. So we look at NH4. First thing we do is put a +1 for the hydrogen. So there's 4 of them, and we know that NH4 has a +1 charge if we look on our periodic table. So we know that nitrogen is -3 in this case. Chlorine then would be -1. Zinc and chlorine is -1 because that's an ion, and we know zinc is +2. Oxygen is -2, and so this must be +3. Again, we have an H3 +1 and -3, so there's been no change in those two. And hydrogen +1 is +1 on this side and -2. So the only changes are your manganese and your zinc. So that is where we're having our redox reaction. All right, so there we go. And so if zinc is oxidized, it's the reducing agent. Manganese is reduced, so therefore it's the oxidizing agent. That's it. Okay, now it's your turn. I'll put this in such a way that it'll be easier for you to determine. I'll give you a couple different questions. All right, this is what you should have figured out. Summarize. As a general rule, a bonded atom's oxidation number is the charge that would have if the electrons in the bond were assigned to the atom, the more electronegative element. An increase in oxidation number of an atom or ion indicates oxidation. A decrease in oxidation number of an atom or ion indicates reduction. Definition of oxidation number. Okay, the big idea, reactions. Redox reactions are identified by changes in oxidation number. And that's it.